Alrighty, so I imagine this is probably going to be more of a time killer or an early out project than it is for a full and complete assignment. But hey, an assignment's an assignment and practice is practice. So whenever we're working with congruent triangles, we're also going to be working with this particular quiz. Apparently it's going to be side, 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 and side angle side. So let's get to work. So for triangles CFE congruent to PTR, complete each of the following statements. So again, if we're working with congruent triangles, even if it's just going to be mapping out sides, even if it's just boring, even if it's just boring, simple stuff like this, I cannot emphasize enough how much easier the project becomes if you do this. So I've got C, F, E, and then that is the same, congruent to PTR. So the way that I drew these is they're congruent. The way that I drew these is congruent to each other relative to their position. So now if I want to look over at CE, so first question CE, look over at CE, I just look over, and in terms of the position, it's just PR. I don't have to scratch my head or try to figure out what it is from the congruent statement. I can just look over at my drawing because my drawing was constructed in a way that reflects everything that you would hear and that reflects everything that you would get from the congruent statement. So TR is going to be FE. CF is going to be TP. Angle P, angle C. Angle E, angle R. Angle F, angle T. Now, this is the real value of it. This is the real value of having the drawing. RPT will be the same as triangle ECF. Triangle FEC is going to be the same as triangle TRP. And then finally, triangle RTP is going to be the same as triangle EFC. And I probably would have gotten that done faster, except it takes me longer to write it down than it does for me to work through it. I mean, that's how fast you can do these sorts of problems if you just have a drawing and if you set up the drawing correctly. I cannot put into words how much easier these problems are with that. All right, so talking about making problems easier, we've got DEF congruent to GJH, and we're finding each missing measure. So we've got numbers over here, so that means we have to put numbers here. Let's see. So DEF, so that means that angle D is going to be equal to G. E is going to be equal to angle J. And then F is intuitively going to be angle H. Alrighty. So let's see. All right, so DF is between reference angles 1 and 3. Over here, between reference angles 1 and 3 is 16 meters. So 16 meters. There we go. JH is between reference angles 2 and 3 over here. Between reference angles 2 and 3 over here is 14 meters. All right. GJ, between here, it's the long side. I don't even probably need to use the reference angles, but it's the long side. And alongside here, 19 meters. All right, pretty straightforward. Let's see, measure of angle F, that's going to be 105. Measure of angle G, that's reference angle 1, so that's 34. Then the measure of angle J, both J and E, I don't have a number for them, but what I do know is that I have two angle measurements of congruent triangles, and so the third has to be the same. So it's 180 minus 105 minus 34, and so that one's going to be 41. And there we go. So moving on to the next one. Given RWS is congruent to TUV, so here we go. T is to T, W, okay, and then S is to V, 1, 2, 3, 1, 2, 3, all right. Find the values of X and Y, all right. Let's see, so for X, that's reference, that's angle reference 1, so T is, all right. I don't have a value for T yet. However, what I do know is that reference angle 3 is equal to 29 over here, which means it's equal to 29 here. I also know that this is 90 degrees. So what that means is this angle plus this angle has to equal 90 degrees. So 90 minus 29 equals 61. So that means 8x minus 27 equals 61. I got 61 because, so the whole triangle is 180. I took out 90 to account for the right angle because that's just 90 gone. I don't need to worry about that. So that means this angle plus this angle has to make up the remaining 90. I took 29 away from 90, and that gave me 61. So that means this angle here has to be 61 degrees, so solve for X that way. So 61 plus 27 equals 8. So X equals 88. 8X equals 88. X equals 11. Yeah, I can work with that. So now I've got to figure out Y. So Y is one of the sides. It's not one of the angles. But my Y over here is between reference angles 1 and 3. So 1 and 3 here. Between 1 and 3 over here, it's 25. All right. So that means 3Y plus 7 equals 25. So 3Y equals 25 minus 7, which is 18. Y equals 6. And there we go. This may have, Y may be a little bit more intuitive, but still, it's, yeah. All right, yeah, we'll move on here. Now we've got a few more congruency statements here. We can get some practice in. We'll start with the first one. Obviously, I mean, we've got to start with the first one. All right, so we have to determine whether the triangles are congruent by side, 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 or side, angle, side. Ooh. So we have two options. We can either be side, 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 or side, angle, side. This first one, we don't have any angles, so that kind of narrows it down. Are there three sides that are congruent to each other? I've got one, I've got two, and then a self-referencing side. So for part A, side angle by SSS. So I'm guessing I say SSS. If congruent, write a congruency statement for part B. I will go yeah, I'll go yeah. Triangle RPQ is similar to triangle SPQ. Because when you're doing a congruency statement, you want to hit the same points in the same order, the same relative points in the same relative order. Having a shared side makes it a little bit more, makes it both more and less complicated, but yeah, there you go. But yeah, I've got one set of congruent sides because these are congruent on both triangles. I've got a second set of congruent sides because these are equal on both triangles. And then a shared side, it's congruent to itself. So these two are congruent by side, side, side. All right, so let's see, is this one side, 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 or side, angle, side? Well, I've got an angle here, so that means I can consider side, angle, side. The problem is that in order to use side, angle, side, the angle has to be between the two sides. So if the congruent angle was for angle V or angle, it has to be angle V and angle Y. Otherwise, I can't use side, angle, side. So that one's out. Can I use side, side, side? Unfortunately, no, because I don't know anything about WZ or XZ. I don't know anything about them at all. They tell me that these two are congruent and those two are congruent. Awesome. But they don't tell me anything about WZ or XZ. So they're not congruent. And yep, there we go. That's it for that one. Let's see. Oh, here we go. All right. So are they congruent by side, 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 or side, angle, side? Oh, that's devious. All right. So, all right. So we don't know what these are. So we don't know the hypotenuse. Normally, I would just say let's use the hypotenuse leg, but we don't know if the hypotenuse are equal to it. Well, technically we do, but so we don't know if the hypotenuse are congruent. They probably are, but we don't know that to be 100%. We do know that this side is congruent to this side. We know that this side, BC, is equal to itself. And we also have an angle between the two sides that are congruent that is equal, that are also equal. So this is actually, when I talked back here, when I was talking about the side angle side, this is actually the perfect implementation of side angle side, because I've got one side that is congruent to another side. I've got one angle that is congruent to another angle that is congruent to the other angle, and then I've got the same side that is congruent to another side. So congruent side, congruent angle, congruent side. The angle is between two sequentially congruent sides. That is congruent by side angle side. So again, the problem with using a shared side is you have to be careful with writing the congruent statements, but it's not like end of the world, but you still want to be careful and make sure that you get it right. All right, so oh yeah, okay. So as I've mentioned with other worksheets, anytime you see parallel angles, that should send up little warning bells in your mind. That should send up little alarm bells or warning bells in your mind that you're going to have to use some other kind of geometric understanding or some other kind of geometric proof in order, excuse me, I apologize, in order to prove your point one way or the other. In this case, I have got, let's see if I can, yeah, I'll get this oriented here. I've got two parallel lines, and I've got a traversal that is going through both of them. And because I've got parallel lines, traversal going through both of them, I know that these two angles are not only corresponding angles, but because these are parallel lines, they are equal to one another. They are angles that are in the same relative position to each other on each of the parallel lines. And because they're parallel and they're attached to the same traversal, they are equal to each other. So because they are equal to each other or congruent to each other, one of the two. So because they are congruent to each other, that means that we've got congruent angles. All right, what's the big deal behind that? Well, if you notice, we have a congruent angle. That means we have a congruent angle between two sets of congruent sides. Congruent side, congruent angle, second congruent side. We have two more triangles that are congruent via side, angle, side. So in this case, I'm going to say triangle JLK is congruent to triangle LNM in the easiest congruency statement with a shared side that I've had to deal with this worksheet. So, all right. So as far as I know, I've got the review coming up and then the final assessment for this unit. So hopefully you all have been keeping up with the studies and the videos. And yeah, you'll be in great shape.